Welcome to Physics Help. This is the second part of multiple choice previous questions from NEET Electrostatics.
Sixth question. A charge Q is enclosed by a Gaussian spherical surface, radius r. If radius is double, then flux will quadruple, double, reduce to half, remain same. Quadruple means it becomes 4 times, double 2 times. We have reduced to half option, remain same option. So we know from Gauss's law, the flux, that is integral E dot dA, flux is equal to Q by epsilon 0, Q enclosed divided by epsilon 0. It does not depend upon, the flux doesn't depend upon which surface, the radius or the dimension. It doesn't depend upon the dimension of the closed surface. We are taking it as the Gaussian surface. So if there is a charge Q here, we take a Gaussian surface here, it is at radius r1, and if we take another Gaussian surface and let it be of radius r2, the flux through each of these Gaussian surface is practically same. This is what Gauss's law says. The dimension of the Gaussian surface is actually immaterial. The flux doesn't depend upon the radius of the spherical Gaussian surface. Therefore, the flux remains the same. Therefore, option 4 is the right answer. The main point in this question we should understand is that the flux depends only on the charge enclosed.
Question number 7. When air is replaced by a dielectric medium of constant K, the maximum force of attraction between two charges separated by a distance increases K times, decreases by K times, increases by K inverse times, remains same. We know the force between two charges Q1 and Q2 separated at a distance r is given by Coulomb's law. F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. In the case of a medium of dielectric constant K, that is, if you are immersing the system of charges in a medium of dielectric constant K, then what will be the change in the force between the two charges? Therefore, F dash is equal to 1 by 4 pi epsilon 0 into dielectric constant K Q1 Q2 divided by r square. So K is same as epsilon r. This is another notation. K is equal to epsilon r. Hence we find that F dash is equal to F divided by K. That is, the force decreases by K times. 8th question. In bringing an electron towards another electron, the electrostatic potential energy of the system becomes 0, increases, decreases, remains same. So to the surrounding of an electron, another electron is being brought in from somewhere, let's say infinity. So since these are of similar charges, same charges, of same polarity, they are bound to face a repulsion, a repulsive force. Therefore, to bring this electron to the vicinity of the other electron, work has to be done to overcome the repulsion. This work done is stored as electrostatic potential energy of the two electron system. And this is actually something that we can see in the Bohr atom model. There are electrons in the same atom. Therefore, there is a electrostatic potential energy in the system of charges or the system of electrons in that atom model. So we can actually calculate this potential energy. The potential energy is equal to work done to bring that charge. Let's say this is a position r vector. This electron is at a position r vector. Therefore, work done in bringing the electron to this position, W is equal to Q into V of r. This Q is electron here, that is E into V of R. V of R is the potential at position R due to the first electron, that is 1 by 4 pi epsilon 0 into E divided by R. That is, potential energy is equal to 1 by 4 pi epsilon 0 into E square divided by R. Therefore, the potential energy of the system increases and its magnitude is approximately the above given expression. Therefore, option 2 is the answer. Question number 9. A hollow insulated conduction sphere is given a positive charge of 10 microcoulomb. What is the electric field at the center of the sphere if the radius of the sphere is 2 meters? So here we have an insulated conduction sphere and it is given a charge 10 microcoulomb. The electric field at the center of the sphere is what we have to find. Let's see if there is an electric field inside the sphere by Gauss's law. We consider a Gaussian surface inside the sphere. Let's see if there is any enclosed charge inside this Gaussian surface. We find that there is no enclosed charge in the Gaussian surface. Therefore, the electric field E inside is equal to 0. Since the center of the sphere is in the interior of the sphere, we can say the electric field at the center of the sphere is also 0. This is actually a direct consequence of the Gauss's law. We can understand this from Gauss's law. This is actually the principle of electrostatic shielding. So inside a closed cavity, the electric field is 0. Therefore, option 3 is the answer. Now let's see the 10th question from the NEET Electrostatic set of questions. Two positive ions, each carrying charge Q, are separated by a distance d. If F is the force of repulsion between the ions, the number of electrons missing is, we have 4 options here. There is a 4 pi epsilon 0 factor in every question. Since Coulomb's law is involved, there is a 4 pi epsilon 0 factor by sure. There is a d square factor also. Let's see what is the answer. The key point to understand is that charge on an ion, or it is a universally we can say charge is quantized. It is a quantization principle. Therefore, in the case of the ions too, the charge on the ion is quantized. That is, the charge on the ion develops due to loss or gain of electrons. It must be maybe 2 electrons or 3 electrons or only 1 electron. Might be gained, electron might be gained or lost. Therefore, Q is equal to plus or minus Ne. Now it is given positive ions. The electrons have been lost. Therefore, the charge Q is equal to plus Ne, or we can say Ne. Since both of the charges are of equal magnitude, we can say Q1 is equal to Q2 is equal to Ne. Therefore, by Coulomb's law, F is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by R squared. Here d squared is the distance. That is 1 by 4 pi epsilon 0 into Q1 Q2. That is Ne into Ne divided by d squared. That is F is equal to 1 by 4 pi epsilon 0 into N squared E squared divided by d squared. Multiplying the denominator to the other side, we have N squared E squared is equal to F into 4 pi epsilon 0 d squared, or N squared is equal to F into 4 pi epsilon 0 d squared divided by d squared. Therefore, N is equal to root of F into 4 pi epsilon 0 d squared divided by E squared. Therefore, option 3 is the right answer. Now let's see the 11th question. A particle of mass m and charge q is placed at rest in a uniform electric field E and then released. The kinetic energy attained by the particle after moving a distance y is QEy, QE squared y, QEy squared, Q squared Ey. So there is an electric field and there is a charge q at rest, and when released, this charge moves through a distance y. And so when it has covered a distance y, what is the kinetic energy attained by the moving charge? That is the question. So the kinetic energy attained by the moving charge on moving through a distance y is the work done by the electric field to move the charge q through the distance y. That is, kinetic energy is equal to work done is equal to F dot D. Here F is equal to EQ, that is the force on charge q by the electric field E. EQ into D. D is nothing but y. And there is a cos theta here. F dot D is FD cos theta. Therefore, there is a cos theta. And here, the displacement and the force are in equal direction. Therefore, it is cos 0 and cos 0 is 1. Therefore, kinetic energy is equal to QEY. Therefore, option 1 is the right answer. Reminding you, these are the questions asked in previous National Eligibility cum Entrance Test NEET examination, which is conducted for admissions to medical colleges in India. Now let's see the 12th question. The electric field at a distance 3r by 2 from the center of a charged conducting spherical shell of radius r is E. The electric field at a distance r by 2 from the center of the sphere is.
We know that for the charged conducting spherical shell, at the distance 3r by 2 from its center O, the electric field is capital E. The question is, what is the electric field at r by 2? R by 2, that is half the radius of the spherical conducting shell, means it is inside the spherical conducting shell. We know inside the spherical conducting shell, inside a closed cavity, electric field is 0. This is electrostatic shielding. Therefore, the electric field is 0. Therefore, option 1 is the right answer.
Question number 13. The electric field in a certain region is acting radially outwards and is given as E is equal to AR. A charge contained in a sphere of radius A centered at the origin of the field will be given by 4 pi epsilon 0 capital A small a cube, epsilon 0 capital A small a cube, 4 pi epsilon 0 capital A into small a square, epsilon 0 capital A into small a squared. So it is given that there is an electric field, and for an electric field there should be a charge or a region of charge, we say. Let's say there is a region of charge here, somewhere here, and due to this an electric field arises. I am drawing the electric field lines. So these indicate an electric field, and the magnitude is given by E is equal to AR. So R may be the distance from the origin to the point where we are considering the electric field. So there is a spherical symmetry. So at the points which are at equal distance from the origin of the field, or we say the center of the charge, will be equal. That is, the points on a sphere or a particular radius would be equal. And this is the symmetry of the problem. Therefore, if we construct a Gaussian surface, we construct a Gaussian surface of radius A, we construct a Gaussian surface of radius A about surrounding this charge, we can find the electric field, and hence by Gauss's law we can find the charge enclosed. By Gauss's law it is closed integral E dot dA is equal to 1 by epsilon 0 into charge enclosed. That is, charge enclosed is equal to epsilon 0 into integral E dot dA. Since the electric field on the surface of the Gaussian surface is same, as we said, explained earlier, epsilon 0 into, we can take E outside, E is a constant for this Gaussian surface, into closed integral dA. Closed integral dA is actually the surface area, the entire surface area of the sphere, that is epsilon 0 E into 4 pi A squared. A is the radius. That is, Q enclosed is equal to 4 pi epsilon 0, and E, we know E is equal to AR, and here the Gaussian surface has a radius of small a, E is equal to A capital A into small a. Therefore, 4 pi epsilon 0 into capital A into small a into a squared, that is equal to 4 pi epsilon 0 a cube. This is the enclosed charge in that region. That is option 1 is the right answer. Question number 14. There is an electric field E in x direction. If the work done in moving a charge 0.2 Coulomb through a distance 2 meter along a line making an angle 60 degree with x-axis is 4 joule, and the value of E. So let's draw a figure. So this is the x-axis, let's say x-axis, and the electric field is along the x-axis E, and the charge 0.2 Coulomb is made to move through a line which is making an angle 60 degree with the x-axis or the direction of the electric field. This 0.2 Coulomb charge moves through a distance of 2 meter. Therefore, we know the work done W is equal to F dot D. This work done is equal to F dot D, that is Fd cos theta. Here F is E into Q into D cos 60 degree here. It is given the question, the work done is 4 joule. Therefore, 4 is equal to E into Q, that is 0.2 Coulomb, into D, that is 2 meter, into cos 60, that is 1 by 2. Therefore, this 2 and 2 get cancelled. Therefore, E is equal to 4 divided by 0.2. Multiply the top and the bottom by 10. We get 40 divided by 2, that is 20 Newton per Coulomb. Therefore, option 2 is the right answer. 15th question. This is another NEET previous year question. But here we are not going to solve this now. We are giving this exclusively for you to solve. You could give the answer in the comment box below, and we will give the right answer in the next video. Thank you.